Welcome to NCERT classes. Okay. Today we'll learn about the differential equations. Okay, this is one of the interesting topics, and some of the problems are very important to understand the integration, differentiation, and the correlation. Okay. So what we learned today is from the differential equations. We have some introduction, basic concepts of the degree and order of the differential equation. Okay, and what a differential equation is made up of, and then general and particular solution of a differential equation, and then methods of solving first order, first degree differential equations. Okay, this chapter is limited to only first order and first degree differential equations. Okay, so let's get into the topic. Differential equation is the equation involving few of the terms. One is dependent variable. You can make it as y or x. Okay. Then independent variable, the other one. Okay. And usually x. Okay. And then derivative of x, which is dy by dx. Okay. So example is dy by dx plus xy equal to 0. Okay. So this is a kind of differential equation. Okay, and this is generally called first degree because the power is 1. Okay, and it is a dy by dx, only one time differentiated. Okay, so differential equation is an equation involving derivatives of a dependent variable with respect to one or more independent variables. Okay, so this is the basic definition of a differential equation. Okay, ordinary differential equation is the differential equation with only one variable is called ordinary differential equation. Okay, example is d square y by dx square plus dy by dx whole square equal to 0. Okay, this is a one example. Now, let's see some definitions of the differential equations. The important one is the degree of a differential equations. Okay, when you think of polynomial, degree is the highest power of the polynomial. Here also it is same. So which means that the differential equation should be defined like a polynomial. Only then degree is defined. Okay, so degree is defined only when the differential equation is polynomial in derivative. Okay, so degree is the highest power of the highest derivative. Okay, the steps are given here, but I'll show you the example, then you will understand easily. Okay, let's say d square y by dx square plus y equal to 0. Here highest order derivative is second order, which is this one, and its power is 1. Its power is 1. So order is 2, degree is 1. Okay, and similarly d cube y by dx cube whole square plus d square y by dx square whole cube plus y equal to 0. Here highest power is 3, but this is not the degree. Okay, you have to first take which one is the highest order derivative, which is d cube y by dx cube. This is the highest order, third order derivative, correct? And its power is 2. So order is 3, power is 2. I mean degree is 2. Okay, order is 3, degree is 2. Now let's say another equation where it is something like this: sine of dy by dx plus y equal to 0. Here derivative is not in polynomial terms, correct? So which means degree is not defined. Okay, so this you have to note. Okay, so degree is defined only if the derivative is in polynomial terms. Okay, similarly we already understood order. Okay, just for definition sake, order of differential equation is the highest derivative present in the equation. That's it, simple. dy by dx equal to e power x, highest derivative is dy by dx, which means order is 1. Okay, so in this one order is 2, this 2, that is. Okay, and in this one the order is 3. Okay, because the highest order is d cube y by dx cube, third order derivative. Okay, hope you understand this one. Okay, ignore the power. Okay, power means for degree. Okay, let's see some exercise. Basic. Okay, determine the order and degree of the differential equations. Okay, here the highest power is, okay, there is a 3 here, there is 4 here. Okay, so highest differentiation term is d4y by dx4, dx power 4. Okay, which means the order is 4, which is very clear, and it is not in polynomial terms because sine y uh, third order derivative is this y dash dash dash, right? This is nothing but dy cube by dx, d cube y by dx cube. Okay, but it is inside sine. Okay, which means the polynomial equation is not present in the derivative terms, which means no degree. Okay, next, y dash plus 5y equal to 0. This is nothing but dy by dx. So here the degree is 1 and order also 1. Okay, Next, ds by dt whole to the power of 4 plus ds d square s by dt square equal to 0. Here highest order derivative is this one, second order. Okay, so order is 2 and its power is 1, so degree is 1. Okay, next. D square y by dx square whole square plus cos of dy by dx equal to 0. Here highest differential term is d square y by dx square, so its order is 2 and it's not in polynomial equation in derivative, so degree, it has no degree. Degree is not defined. Okay, d square y by dx square equal to cos 3x plus sin 3x. Here highest order is 2 and its power is 1, so degree is 1, order is 2. Okay, next. Okay, here highest order is 3 and its power is 2, so order is 3, power is 2. Oh, sorry, degree is 2. Okay, next. Yeah, here it is almost similar to that one. Order is 3 and degree is 1. Okay, yeah. So here order is 1. Okay, degree is 1. Okay, here order is 2. This is a yes one, right? And the degree is 1. Its power is 1. Okay, yeah. Here sin y, there is no derivative in this, so it's okay. So order is 2 and the degree is 1. Yeah, here highest order is d square y by dx square, so its order is 2 and its power is 3, so which means degree is 3. Oh, sorry, degree is not defined because derivative is inside this one. Okay. So sin dy by dx is there, so derivative is not in a polynomial. Polynomial is not in derivative terms, so it's not defined. Okay. Degree is not defined. Order is always there. Yeah. 2x square d square y by dx square minus 3 dy by dx plus y equal to 0. Here highest order is 2, which is here, and its degree is 1. Okay. So yeah, these are the simple exercises to understand degree and order. Okay. Let's do next exercise, which is 9.2. In this exercise, what we will do is two equations will be given, and one is the solution of the other equation, other differential equation. Okay, so we need to prove that. How we will do that? Let's see. So first one is y equal to ex plus 1 and y double dash minus y dash equal to 0. Clearly you can see this is the differential equations and this is the other equation. So we need to prove that this is the solution of this differential equation. How do we do? Y is given explicitly. Okay, there is no mix of variables here, so find out y dash, y double dash. Okay, so y dash is e to the power of x, y double dash also e to the power of x, so y double dash minus y dash is obviously 0. Okay, which is RHS. So y equal to ex plus 1 is the solution of y double dash minus y dash equal to 0. This is the differential equation and this is the solution. Okay, similarly all the problems will do. We need to prove the first equation is the solution of the second differential equation. Okay, so y equal to x square plus 2x plus c and y dash minus 2x minus 2 equal to 0. So this is also very clear. Find out directly y dash. Y dash is nothing but 2x plus 2. So y dash minus 2x minus 2 equal to 0. So this is the differential equation. Okay. Y equal to cos x plus c and y dash plus sin x equal to 0. So you take this one and differentiate this. So y dash equal to minus sin x. Okay. So y dash plus sin x is equal to 0, obviously, right? So y equal to square root of 1 plus x square and y dash equal to xy divided by 1 plus x square. So you take the y, differentiate this, or you take y square, consider this as y square 1 plus x square. So 2y y dash equal to 2x, 2y y dash, I am differentiating on both sides, right? Now y dash is nothing but 2x by y, y dash is x by y, x by y is nothing but given square root of 1 plus x square, so substituted back here. So this will become x by y equal to, right, sorry, y dash equal to x by 1 plus x square. Okay, now if I multiply both the denominator and numerator with this square root of 1 plus x square, this will become x into square root of 1 plus x square divided by 1 plus x square. Okay, now this one we know that this is nothing but y dash, sorry, y, this is nothing but y. Okay, so this is nothing but xy divided by 1 plus x square equal to RHS. Okay, this is same. So we need to make sure that we come to the given differential equation. Okay, so that this will become solution of the given differential equation. Okay, y equal to ax and xy dash equal to y. So obviously this will take differentiate y dash equal to a. So now you substitute x into a, that is xa equal to y, correct? So this is straightforward. Okay, next y equal to x sin x and xy dash equal to y plus x into square root of x square minus y square. Okay, so this one, yeah, y equal to x sin x, okay, or sin x equal to y by x. So cos x is nothing but square root of 1 minus sin square x, which is nothing but square root of 1 minus y square by x square, which is square root of x square minus y square by x. Okay, this you should note down. Okay, now take this equation and find out the differentiation. So y dash is equal to, we have to apply UV product rule for differentiation. So sin x plus x cos x. Okay, now cos x we have the value, substitute it. Okay, so LHS is xy dash. So xy dash is nothing but x sin x plus x square cos x. Okay, now sin x and cos x values you have, you substitute them. Okay, so x into y by x plus x square into square root of x square minus y square by x, which is nothing but y plus x into square root of x square minus y square, which is nothing but RHS given here. Okay, so this is the how we should prove. Okay, xy equal to log y plus c and y dash equal to y square by 1 minus xy. Okay, xy equal to log y plus c, which implies, okay, if I differentiate y plus xy dash equal to y dash by y, log y, if I differentiate, this is 1 by y into y dash, which is y dash by y. Okay, now I need to just adjust this, that's all, right? So this is nothing but if I take xy dash to other side, it will become y equal to y dash by y minus xy dash. I take y dash common, so and this 1 by y minus x I will simplify. So this will become y dash into 1 minus xy by y. Okay, this is nothing but what we are trying to get it here, correct? So y square equal to y dash into 1 minus xy, which means y dash equal to y square by 1 minus xy. Okay. Yeah. Next one is y minus cos y equal to x and y sin y plus cos y plus x into y dash equal to y. Okay. So y equal to x plus cos y. Now y dash into y dash plus y dash sin y. Okay, y dash sin y. If I differentiate this, basically y dash plus y dash, I mean sin y minus minus sin y, minus into minus is plus, so plus sin y into y dash equal to 1, because this side is only x is there. Okay, now I need to substitute the values appropriately. Okay, LHS is given y into sin y plus cos y plus x into y dash. Okay, this is the LHS side. Now what are the things I will take out of this? Okay, this is nothing but y sin y plus cos y plus x is nothing but cos y plus x is nothing but y. So I will write it as y. So this is nothing but y sin y, if I take y common, y into sin y plus 1 into y dash, sin y plus 1 into y dash. And now what is this sin y plus 1 is nothing but if I take y dash common, okay, y dash is nothing but 1 by sin 1 by 1 plus sin y, correct? Or 1 plus sin y equal to 1 by y dash. So this will become 1 by y dash. 1 by y dash into y dash is 1. So this is y, RHS. Okay. X plus y equal to tan inverse of y. Then y square y dash plus y square plus 1 equal to 0. Okay. Differentiating basically this equation solution. So 1 plus y dash equal to tan inverse y differentiation is 1 by 1 plus y square into y differentiation is y dash. Okay, now just adjustment only. Okay, take the denominator to other side, it will become 1 plus y dash into 1 plus y square equal to y dash. Expand it, 1 plus y square plus y dash y square equal to y dash. Okay, now simplify it, this will become y plus y square plus y dash y square equal to 0. Okay, y equal to square root of a square minus x square, where x is belongs to minus a to a, and x plus y dy by dx equal to 0. Okay, so this is my, if I square it, this will become y square equal to a square minus x square. So 2y y dash equal to minus 2x, or if I cancel 2, y dash equal to minus x. Okay, y dash is nothing but dy by dx equal to minus y. So this is straightforward, x plus y dy by dx equal to 0. That's what we get it. Okay, next. The number of arbitrary constants in the general solution of a differential equation are, okay, differential equation of fourth order, which means d to the power of 4 y by dx power 4. Okay, in that you will find whatever is the order, basically so many arbitrary constants are possible, so answer is 4. Okay, the number of arbitrary constants in a particular solution of a differential equation are 0. Okay, in a particular solution you will not have any constants, all constants are calculated, that's why we call it as particular solution. Okay, methods of solving first order first degree differential equations. Okay, so this is very important thing to understand. There are multiple ways to solve the differential equations. Very basic way is, okay, very basic way is this one. Okay, here what we will do is variable separable form. Okay, so we separate the variables into two groups and then solve them independently. If I show you one example, you will understand very easily. Okay, let's say dy by dx equal to f of x into g of y. Okay, where f of x and g of y are completely separate. Okay, they are not basically mixed. Okay, it is not f of x comma y. Okay, it is not f of x comma y. F of x is independent and g of y is independent, it is just a product. So if you can split it like this, okay, then you take the g of y to LHS side and d of x to the RHS side, then it will become dy by g of y equal to f of x into dx. Now you integrate both sides. Okay, you will get the solution, correct? If I integrate dy by g of y, which is equal to integration of f of x dx. Now you find out these two integrations separately, that's the solution of the this differential equation. Okay, so this is one method. Now we will solve in the next exercise, that is exercise 9.3, we will solve all the problems based on this first concept. Okay, there are more concepts are there which will come further. So this is the first one we will do based on this formula. Okay, this first principle. Find the general solution of the differential equation. Okay, so dy by dx equal to 1 minus cos x by 1 plus cos x. Okay, this is a straightforward thing, right? So dy by dx is, I will write 1 minus cos x as 2 sin square x by 2 and 1 plus cos x as 2 cos square x by 2, which is tan square x by 2. So my y is nothing but integration of tan square x by 2 dx, which is secant square x by 2 minus 1 dx integration of. So this is nothing but y is equal to tan x by 2 by half minus 1 integration is x, okay, plus constant. So that is nothing but 2 tan x by 2 minus x plus c. This is what y. Okay, this is the solution of the given differential equation. Next, dy by dx equal to square root of 4 minus y square. Okay, and y is between minus 2 and 2. This is also straightforward. Okay, dy by square root of 4 minus y square equal to dx. If I integrate it both sides, I get x equal to integration of dy by square root of 4 minus y square. This is in the form of sine, basically sine inverse. So x is equal to sine inverse of y by 2 plus constant. Or I can rearrange this in a such a way that x minus constant is equal to sine inverse of y by 2 and y is equal to 2 times sine of x minus c. Okay, this is how we can simplify the given solution. Next, dy by dx plus y equal to 1. Okay, so dy by y minus 1 equal to dx, or x is equal to integration of dy by 1 minus y, which is equal to minus of integration of dy by y minus 1. Okay, this is nothing but we know log of y minus 1. Okay, so x is equal to minus log of y minus 1 plus constant, or you take it to other side, it will become x plus log of y minus 1 equal to constant. Okay, this is a better way of representing, that's all. This is also a solution. Next, secant square x tan y dx plus secant square y tan x dy equal to 0. Okay, it has mixed of x and y terms actually, so separate them. So this will become secant square tan y. Okay, this is a given expression. You divide with the tan x tan y. So this will become, if I divide this expression with the tan x into tan y, this will, I am left with secant square by tan x dx plus secant square y by tan y dy equal to 0. Now integrate this whole expression. This will become integration of secant square by tan x dx plus integration of secant square y by tan y dy equal to 0. If I take tan y as t, secant square this tan x as t, secant square x dx is dt. So this is as simple as log of tan x plus log of tan y equal to constant. Okay, I can say this constant as log k. Okay, then this will become tan x into tan y equal to k. This is the solution. Okay, next. e to the power of x plus e to the power of minus x dy minus e to the power of x minus e to the power of minus x dx equal to 0. Okay, take everything to x terms separate basically. So dy is nothing but e to the power of x minus e to the power of minus x divided by e to the power of x plus e to the power of minus x dx. Integrate it on both sides. What you will get is, if you consider this as t, okay, then this numerator dx is dt. Okay, so my solution is nothing but log of denominator, which is log of e to the power of x plus e to the power of minus x plus constant. This is the solution. Okay, y is equal to, this is the solution. dy by dx equal to 1 plus x square into 1 plus y square. Now separate them carefully. dy by 1 plus y square equal to 1 plus x square into dx. Integrate on both sides, you get integration of dy by 1 plus y square equal to integration of 1 plus x square dx. Okay, so this is nothing but we know tan inverse of y, which is equal to integration of 1 is x, integration of x square is x cube by 3 plus constant. Y log y dx minus x dy equal to 0. Now again separate the terms properly. Dy by y log y equal to dx by x. Okay, integrate on both sides, you get integration of dy by y log y equal to integration of dx by x. Okay, now you consider log y as t, then 1 by y dy is dt. So this is nothing but log of log y is the answer. Correct? Log of log y, which is equal to log of x plus log of c, constant I will call it. So this side is nothing but log of xc. Correct? So if I remove the log on both sides, this will become log y equal to xc, plus or minus xc basically. Okay, if I consider plus or minus c as a, capital A, then I can call it this as ax. Okay, so my answer is y is equal to e to the power of ax. This is the solution, more simplified and better way of representing. X to the power of 5 dy by dx equal to minus y to the power of 5. Okay, now pull the terms carefully to same side. So dy by y to the power of y equal to minus of dx by x to the power of 5. Integrate on both sides. What you will get is solution x to the power of minus 4 plus y to the power of minus 4 equal to k. Okay, next. dy by dx equal to sine inverse of x. Okay, so this we just need to apply product rule of integration. That's all. Okay, so f of x is highlight rule. If you consider in inverse trigonometry is first, so f of x is sine inverse f x and g of x equal to 1. Okay, so I is equal to, that is y basically in this case. Okay, sine inverse x into integration of 1 is x minus integration of differentiation of sine inverse of x is 1 by square root of 1 minus x square into integration of 1 is x dx. Now you do this integration separately. 1 minus x square equal to t, if you take minus 2x dx is dt. Okay, so integration of x by square root of 1 minus x square dx is nothing but 1 minus minus half integration of dt by square root of t, which is nothing but minus square root of t or minus square root of 1 minus x square. Okay, now you substitute everything in this. This y is equal to x sine inverse of x plus square root of 1 minus x square plus k. Okay, next, e to the power of x tan y dx plus 1 minus e to the power of x into sine square y dy equal to 0. Okay, so again pull the terms to same side. Minus e to the power of x by 1 minus e to the power of x dx equal to secant square y by tan y dy. Okay, now integrate on both sides. Okay, what you will get is, if I consider 1 minus ex as t, minus ex dx is dt. Correct? And consider tan y as t or m, other variable, secant square y dy equal to dm. Okay, so now if I substitute, this is nothing but integration of dt by t equal to integration of dm by m. Okay, so which is nothing but log of 1 minus e to the power of x equal to log of tan y plus constant. Consider this also as log c or something. This will become tan y by 1 minus e to the power of x equal to c. Okay, so this is the simplified solution. Okay, you can remove the absolute modulus also actually, because you can consider c as anything plus or minus c, right? Yeah, next. Find the particular solution of the differential equation. Okay, so x cube plus x square plus x plus 1 dy by dx equal to 2x square plus x. Now you take all the dy by dx and other terms. Okay, so and given information is y equal to 1 when x equal to 0. Okay, this we will use once we get the solution of this differential equation. Okay, so dy by dx is nothing but 2x square plus x by x cube plus x square plus x plus 1. So at this stage you can solve it in two ways. One is use partial fractions to divide this one. Okay, denominator can be easily expressed in terms of factors. Otherwise you express the numerator in terms of denominator plus differentiation of denominator. Okay, that is also other way. Let's do this way, partial fraction method. So 2x square plus 1 by x cube plus x square plus x plus 1 can be written as 2x square plus 1, sorry, 2x square plus 1. Okay, sorry, okay, given it is 2x square plus x is correct, so this is x here. Okay, divided by x cube plus x square plus x plus 1, I can write it as x plus 1 into x square plus 1. Okay, now this can be divided into partial fractions, a by x plus 1 plus bx plus c by x square plus 1. Solve the partial fractions, you will get a equal to half, c equal to minus half, b equal to 3 by 2. So this is my dy by dx. Now just integrate on both sides. Okay, this is the solution once you integrate this. Okay, we know this one is log x plus 1 by 2 log x plus 1, and this one we need to use x square plus 1 as t, so that you get 2x dx is dt. Okay, so x dx is nothing but dt by 2. Then you solve this one, and here this is tan inverse, right? 1 by 2 tan inverse x. Okay, so this is the one. I2 is important for us because we need to solve it using by taking temporary variable, that is x square plus 1 is t, so x dx is dt by 2. So my I2 is nothing but 3 by 2 integration of dt by 2t, which is 3 by 4 log t, or 3 by 4 log x square plus 1. So my integration is y is equal to half log x plus 1 for this. Okay, and I2 is nothing but 3 by 4 log x square plus 1 minus half tan inverse of x plus k. Now I need to substitute y equal to 1, x equal to 0. Okay, with that I get the value of k. Okay, if I substitute y equal to 0, y equal to 1 when x equal to 0, what I will get is this is 0. If x equal to 0, this is also 0. Okay, if x equal to 0, this is also 0. So k equal to 1. Okay, once I know k is equal to 1, my particular solution is y is equal to half log x plus 1 plus 3 by 4 log x square plus 1 minus half tan inverse of x plus 1. This is the particular solution. Okay, hope you understand how to use this information, okay, to find the particular solution. Okay, we use this information only to find the constant value, that's it. Okay, next. X square into x into x square minus 1 dy by dx equal to a when, and y equal to 0 when x equal to 2. Okay, this is to find out the constant. Okay, otherwise you solve this one, that's it. Dy by dx is a by x into x square minus 1, I can write it as x into x minus 1 into x plus 1. Again, I can use partial fractions to split this. Okay, so with this I get my ABC. A is minus 1, a is minus 1, b is half, c is half. Okay, now my integration is nothing but dy by dx equal to minus a by x plus a by 2 into x plus 1 plus a by 2 into x minus 1. Now I integrate on both sides, I get the y value. Okay, so y is equal to integration of this, which is nothing but minus a log x, this is a by 2 log x plus 1, this is a by 2 log x minus 1 plus k. Now I can actually combine all these things together into single log, that is nothing but y is equal to a log, okay, modulus of square root of x square minus 1 by x plus k. Now I use this one, y equal to 0 when x equal to 2. When x equal to 2, what happens? This will become 4 minus 1, that is square root of 3 by 2, correct? So this is nothing but a log square root of 3 by 2, which is equal to 0 plus k is there, sorry. Okay, so k is nothing but minus a log of square root of 3 by 2. Now my particular solution is y is equal to minus a log square root of x square minus 1 by x minus a log square root of 3 by 2. You can combine these two also. Okay, if you want, you can combine these two and write it as a single log, or you can express this as a e to the power of a by y. Okay, that is also another way, but yeah, this is the solution. Next, cos of dy by dx equal to a, y equal to 1 when x equal to 0. Okay, so dy by dx is nothing but cos inverse a, and cos inverse a is a constant. Okay, this is no x, no y involved in this. So y is nothing but integration of cos inverse of a dx, which is nothing but cos inverse of a into x plus k. Now you substitute, correct? Y is equal to, this is the solution, y is equal to 1 when x equal to 0. When x is 0, this value is 0, so k is 1, correct? So my particular solution is y equal to cos inverse of ax plus 1, or I can rewrite this as a equal to, okay, y minus 1 by x and then cos inverse will come to other side, it will become cos. So A is equal to cos of y minus 1 by x. This is the particular solution. dy by dx equal to y tan x, y equal to 1 when x equal to 0. Okay, so dy by y equal to tan x dx. So integrate on both sides, you get log y equal to log of secant x. So I am writing constant in terms of log only so that it is convenient, plus log c. So y is nothing but c secant x. Okay, where c can be either plus or minus k, it can be anything. Now let's find out using this particular solution. So y equal to 1 when x equal to 0. So y equal to 1 equal to c into secant 0. Secant 0 is 1. So that means c is 1. Correct. So my particular solution is y equal to secant x. This is the solution of this differential equation. Find the equation of the curve passing through the point 0, 0 and whose differential equation is y dash equal to e to the power of x sin x. Okay. So y dash is nothing but dy by dx. We know it, right? So this is the curve passing through this one and whose differential equation. That means tangent slope of the tangent basically. Correct. So y is equal to integration of e to the power of x sin x dx is the solution of the curve. Correct. Now you can apply product rule. F of x equal to sin x, g of x equal to e power x. How did you guys highlight? We apply. Okay. In this one, e exponential is the last, so this is g of x. Okay. Tangential is just before exponential, so this is my f of x, first function. So first time when I do apply this one, I get y is equal to sin x e to the power of x minus integration of cos x e to the power of x dx. Now again you apply product rule on this one. What you will get is sin x e to the power of x as is minus. Okay, this value will become cos x e to the power of x plus integration of sin x e to the power of x dx. Now this is nothing but y again. Correct. So this is nothing but y. So this will become e to the power of x into sin x minus cos x minus y, or y is equal to e to the power of x by 2 into sin x minus cos x plus constant k. Now I know that this curve is passing through 0, 0, which means this equation satisfies 0, 0. So substitute 0, 0. Sin 0 is 0, cos 0 is 1. Okay, and e to the power of 0 is 1, so minus 1 by 2. Y is equal to minus 1 by 2 plus k, and y is also 0. So 0 equal to minus 1 by 2 plus k, or k is equal to 1 by 2. Correct. Now my equation of the curve is nothing but y is equal to e to the power of x by 2 into sin x minus cos x plus half, or 2y minus 1 equal to e to the power of x into sin x minus cos x. Okay. Next. For the differential equation xy dy by dx equal to x plus 2 into y plus 2, find the solution of the curve passing through the point 1 comma minus 1. Okay. Now this is the differential equation. This is the which is the solution of this one is the curve. Okay. So if I separate the terms, y dy by y plus 2 equal to x plus 2 by x into dx. Now integrate on both sides to get the curve equation. If I integrate this one, I can write y as y plus 2 minus 2. Okay. And here nothing, I just divide, so I'll get 1 plus 2 by x. Okay. So integration of this one will become integration of 1 minus 2 by y plus 2 dy equal to integration of 1 plus 2 by x dx. That is nothing but y minus 2 log y plus 2. This one equal to this integration is x plus 2 log x plus constant. Okay, now I know that this is passing through 1 comma minus 1. Correct. So that is nothing but 1 minus of minus 1 plus 1 plus 2 log x into y plus 2. Correct, which is nothing but 1 into 1, that is log 1 plus k equal to 0, or k is minus 2. Okay, from this you can derive k is minus 2. If once I know this one, my curve is nothing but x minus y plus log of x into y plus 2 whole square. Okay, minus 2 equal to 0. Okay, next. Find the equation of the curve passing through the point 0 comma minus 2, given that at any point x comma y on the curve, the product of the slope of the tangent and y coordinate of the point is equal to the x coordinate of the point. Okay. So first thing is find the equation of the curve passing through this point, given that at any point x comma y on the curve, product of its slope. Okay. How do you get the product of the slope at any point? dy by dx. So dy by dx equal to, right, that is the product of the, that is the slope of the tangent. Okay. So product of slope of tangent, that is dy by dx into y coordinate, that is y, is equal to x. This is the equation. This is the slope of the tangent of the curve dy by dx. Given that dy by dx into y equal to x, or y into dy equal to x into dx, integrate on both sides. Okay, you get y square by 2 equal to x square by 2 plus c. Okay, now we know that this curve is passing through 0 comma minus 2. Correct? 0 comma minus 2 it is passing through. So let's substitute. What you will get is minus 4 equal to k constant. So my equation of the curve is x square minus y square plus 4 equal to 0. Okay, next. At any point x comma y of a curve, the slope of the tangent is twice the slope of the segment joining the point of contact to the point minus 4 comma minus 3. Find the equation of the curve given that it passes through minus 2 comma 1. Okay, so this is simple. First thing is find out this is the slope of tangent of any curve, which is dy by dx. Okay, now this is nothing but twice the slope of the segment joining point of contact and this point, right? Let's say slope of point of contact is x comma y. So slope of the line joining these 2 points is nothing but y plus 3 by x plus 4. Now given that dy by dx equal to 2 times this slope, that is y plus 3 by x plus 4. Okay, now you separate the terms. Dy by 2 times y plus 3 equal to dx by x plus 4. Integrate on both sides. Okay, what you will get is half log y plus 3 equal to log x plus 4 plus k. Now it is given that information that it is passing through minus 2 comma 1. Correct? This is passing through minus 2 comma 1. So this is simplification of this same one. Okay, now if I substitute the values, I get minus 2 comma 1, right? So 1, if I substitute here, this will be 2 by 3. Okay, log of 2 by 3, which is equal to log c, or y plus 3 equal to c times x plus 4 whole square. This also I can take it. So y is 1. So 4 equal to 1 plus 3 equal to c times minus 2 plus 4 whole square. That means c is nothing but 1. Okay, so my equation is nothing but x plus 4 whole square minus 5 minus 3 equal to 0. This is the equation of the curve. Okay, parabola. Next. The volume of spherical balloon being inflated changes at a constant rate. If initially its radius is 3 units and after 3 seconds it is 6 units, find the radius of balloon after t seconds. Okay, so first thing is volume 4 by 3 pi r cube, which we know, of a balloon, of a sphere. dv by dt, which is equal to 4 pi r square dr by dt, which is constant, that is k. Okay, now once I know this one, this is very simple. Okay, so pi r square dr equal to k dt. Now integrate on both sides. Okay, integrate on both sides. Then what I'll get is 4 by 3 pi r cube equal to kt plus constant. Okay, here k is a constant, c is a constant. So I need two informations to solve this k and c. Correct? So there are two given actually. Initially its radius is 3 units, means t equal to 0, r equal to 3. After 3 seconds, that is t equal to 3, r is 6. Now you substitute one by one, you will get both the values, right? 4 by 3, 3 cube, 4 by 3 pi 3 cube equal to 0 plus c, which means c is 36 pi. Now you substitute all that, you will get k value. K is nothing but 84 pi. Okay, now my equation is nothing but 4 by 3 pi r cube equal to 84 pi t plus 36 pi. Or I can simplify it further. R cube equal to 63t plus 27, or you can also write r equal to 63t plus 27 whole to the power of 1 by 3. Okay. In a bank, principal increases continuously at a rate of r% per year. Find the value of r if 100 is doubled itself in 10 years. Okay, log 2 to the base e is given, which is 0.6931. Okay. So let the principal be p. Then what they are telling is principal increases continuously at a rate of r%, which means dp by dt, rate of increase of principal, is r by 100 into p. Okay, which means dp by p equal to r by 100 into dt. Okay, integrate on both sides. What you will get is log p equal to r by 100 is constant for dt, right? So r by 100 into t plus k. Now you substitute the values. Okay, at t equal to 0, p is 100. At t equal to 10, p is 200. These are the two values we will substitute. So first thing is log 100 equal to 0 plus k, which means k is nothing but log 100. Fine. So log 200, that is p is 200, equal to 10r by 100 plus log 100. Now here I get my r by 10 is nothing but log 2, or r is 0.6931, okay, which means into 10, which means 6.931. This is my r, rate of interest. Okay, so we are supposed to find the rate of interest, which is 6.931. Okay, now next. Okay, same thing if you want to, instead of integration, if you want to try in simple formula, okay, you may do a mistake actually. That's why I'm giving it here. You may do a mistake that you will take PTR by 100. Okay, R equal to interest equal to PTR, I equal to PTR by 100 you will take, and that's not correct actually. Okay, it is continuously increasing at a rate of R% per year, which means you should take S is equal to P times e to the power of RT by 100. This is what you should take. Okay, so if you consider this one, okay, now information is given at 200, that is correct. It doubles in 10 years. So 200 equal to 100 times e to the power of 10r by 100. Okay, 10r by 100 is 2 is equal to e to the power of RT by 100, or log 2 equal to RT by 100, r by 10, which is r by 10 because t is 10. Okay, now r is nothing but log 2 into 10, which is nothing but 6.931. Same thing we'll get. Okay, so this is what you should use. Next. This is also exactly similar problem to the last one. Only thing is interest, there is a difference actually. Okay, and initial amount. So I think you can solve it yourself. Okay, you can solve it yourself. Try it. You can get the principle here in this case. General solution of a differential equation dy by dx equal to e to the power of x plus y. Okay, this is very simple. Dy by dx is e to the power of x plus y, or e to the power of x into e to the power of y. Separate that. Dy by e to the power of y equal to e to the power of x into dx. Integrate on both sides. What you will get is minus e to the power of minus y equal to e to the power of x plus c, or e to the power of x plus e to the power of minus y equal to k. Okay, this is the solution of the general solution of the differential equation. Next. Yeah, let's learn another way of solving the differential equations, and then solve the exercise problems related to that. Let's learn the other method of solving the differential equation. Okay, so in this method, first we need to understand the degree of the homogeneous function. Okay, so if a function, okay, f of x comma y, I mentioned it as capital F because it has a integration in it. Okay, a differentiation, result of a differentiation basically. Okay, is said to be homogeneous function of degree n if replace f of ax comma ay. That means you replace x with ax, y with ay, then you get a to the power of n into f of x comma y. Okay, for any non-zero constant a. Okay, then this is called homogeneous equation of degree n. Okay, example, if I take f of x comma y as y square plus x plus y square plus xy. Now I replace f of x with ax, y with ay, then it will become f of ax comma ay is nothing but, okay, a square y square plus a square xy. If I take a square common, this will become a square into y square plus xy, which is nothing but f of x comma y. Correct? So this is nothing but a square f of x comma y. So this is degree 2 because a square, right? That's why degree 2. Okay. Suppose if the f of x comma y is like this, cos of y minus x, then f of ax comma ay is nothing but cos of y by x. Again, a in numerator, a in denominator gets cancelled. So this is nothing but a to the power of 0 into f of x comma y. Okay, this is degree 0. Okay, so you understand what is the degree now. So any homogeneous function, if it is in this form, where if I replace x with ax, y with ay, I still again get f of x comma y into some constant. Okay, a to the power of 0, a to the power of n. Then you can solve this equation very easily using this method. Okay, how you can solve this one? You replace, okay, dy by dx is f of y by x. This is in this form. You substitute y equal to vx, or y by x equal to v. Y by x equal to v. Okay, that means y equal to vx. If I differentiate, dy by dx equal to v plus x dv by dx. Okay, I am applying product rule on this one. Now with this one, you can solve the problem. Now dy by dx is v plus x dv by dx, which is equal to f y by x. With this, you can solve the differential equations. Okay, only thing is note down you can also make dx by dy also. Some equations it is easy to make dx by dy, and then you in that case you call x equal to vy, okay, and then dx by dy equal to v plus y into dv by dx you will get, okay. So that way also you can solve. This is the way you solve any homogeneous differential equation. So let's do one exercise based on this concept alone, okay. Show that the given differential equation is homogeneous and solve each of them. First thing is we should show that this is homogeneous equation. How do you do that? You replace x with ax, y with ay, correct? So let's say first question is x square plus xy into dy equal to x square plus y square dx. Now we can call this dy by dx equal to x square plus y square by x square plus xy, which is nothing but my f of x comma y. Now f of ax comma ay is I get only a square term in each term will have a square product. If I take a square common, this will be a square into x square plus y square divided by a square into x square plus xy, which is nothing but a to the power of 0 into f of x comma y. Same, correct? So this is degree 0. This is the homogeneous equation of degree 0. How to solve this? You take y by x equal to v, or y equal to vx, or dy by dx equal to v plus x dv by dx, okay. Now you equate what is your dy by dx. This is the dy by dx. Substitute here, okay. So v plus x dv by dx is nothing but x square plus, okay, y is nothing but vx, so v square x square divided by x square plus x into vx, that is vx square. Now we take x square common, this will become 1 plus v square divided by 1 plus v. Now this v is there, take it other side. X dv by dx equal to 1 plus v square divided by 1 plus v minus v, which is nothing but 1 minus v by 1 plus v, 1 minus v by 1 plus v, okay. Now 1 plus v into dv divided by 1 minus v. I am bringing all the v terms onto one side, x terms onto the other side, which is equal to dx by x. Now I can integrate this, correct? If I integrate this now, integrate on both sides, what I will get is this I can write 1 plus v by 1 minus v, I can write it as 2 minus 1 minus v by 1 plus v, correct? So this will become 2 by 1 minus v minus 1. Correct. So integration will give me integration of 2 by 1 minus v minus 1 dv, which is equal to integration of dx by x. Okay. So this is nothing but minus 2 log of 1 minus v minus v, which is equal to log of x plus constant k. I can make this because both sides we have logarithm. You can also call it log c or something, but this is okay, right? Now replace v with y by x. So log x plus 2 times, right? So 2 will go to square. So 1 minus y by x whole square plus y by x, okay, plus y by x, v is y by x, right, equal to c, okay. This is my differential, this is my solution to the differential equation, okay. So if I simplify this further, it will become log of x minus y whole square divided by x plus y by x equal to c, okay. So this is how you solve the homogeneous equations of degree n, okay. Here we have showing degree 0 basically, okay, but any problem we will solve it same way, okay. Next, y dash, which is dy by dx equal to x plus y by x, which is more simple actually compared to that. So dy by dx equal to x plus y by x, which is my f of x comma y, replace x f of ax comma ay is nothing but a to the power of 0 f of x comma y. This is degree 0, homogeneous equation of degree 0. So y by x equal to v, or dy by dx equal to v plus x dv by dx, okay. Now dy by dx I'll substitute v plus x dv by dx equal to, okay, x plus vx by x, or that is nothing but 1 plus v and v both sides gets cancelled. I'll left with x dv by dx equal to 1, or if I take the terms separately, dv equal to dx by x. Integrate on both sides, you'll get integration of dv equal to integration of dx by x, or v is equal to log of x plus k, or log of c I can call this one, okay. So y by x equal to log of x plus log of c, or log of cx, okay. So I can write this as y is equal to log of cx to the power of x, x goes to the other side, so this will become cx whole to the power of x, okay. Or I can also write this as cx whole to the power of x equal to e to the power of y. This is my solution to this differential equation, okay. So this is how we will solve all the problems. We will solve it same way. Okay, so this one x minus y dy minus x plus y dx equal to 0. First is, what is my dy by dx? X plus y by x minus y, which is my f of x comma y. F of ax comma ay is nothing but a to the power of 0 into f of x comma y. So this is of homogeneous equation of degree 0. So y by x equal to v, or dy by dx equal to v plus x dv by dx. If I substitute, this is what I get, and my x dv by dx is nothing but 1 plus v by 1 minus v, which is v square plus 1 by 1 minus v. If I bring all the v terms to one side, I'll get 1 minus v divided by 1 plus v square dv equal to dx by x. Integrate on both sides, you'll get this one, right? Now this I'll split it, 1 by 1 plus v square minus v by 1 plus v square. Okay, dv both sides, and integration of dx by x. This I know, this is log x. Okay, now here this is nothing but tan inverse of v minus, this is nothing but minus half 2v by 1 plus v square dv. So if I take 1 plus v square as t, then 2v dv is dt. So this is nothing but log of 1 plus v square, correct? This is log of 1 plus v square. Minus of is as is. So tan inverse v minus half log of 1 plus v square, which is equal to log x plus k. Just rearrange the words and replace v with y by x. Tan inverse of y by x equal to y by x minus half of log 1 plus v y square by x square is equal to log x plus k. Okay, you can simplify, take the logarithm terms to one side. So tan inverse y by x equal to half of log y square plus x square plus c. Okay, this is the solution to the differential equation. Okay, x square minus y square dx plus 2xy dy equal to 0. So my dy by dx is nothing but y square minus x square by 2xy, which is a homogeneous equation in order degree 0. Okay, so same way you will solve it. Okay, here you will get, when you take all the v terms to one side and x term to one side, you will get minus 2v by 1 plus v square dv equal to dx by x. This is more simple actually, right? So take minus out, 1 plus v square equal to t, 2v dv is dt. So this is nothing but minus log 1 plus v square. Okay, minus log 1 plus v square. That's what you'll get. Okay, so minus log 1 plus v square is nothing but y square by x square, which is equal to log x plus log k. Okay, so I will call it log xk. Okay, and this side it will become, if I take all the log out, basically this is nothing but x times x square plus y square by x square. This is what, x square plus y square by x square is equal to c. Another constant I just put, you can also call it k. And if I simplify this further, okay, this will become x square plus y square equal to cx. Next, x square dy by dx equal to x square minus 2y square plus xy. Okay, so my dy by dx is nothing but 1 minus 2 y by x whole square plus y by x. Okay, already you can clearly see this is a homogeneous equation of degree 0. Okay, so you again use exactly same method and bring all the v terms to one side, x term to other side. So dv by 1 minus 2v square equal to 1 by dx by x. Integrate on both sides. Okay, so integration of 1 minus 1 by 1 minus 2v square dv, I can write it as integration of 1 by 1 minus square root of 2v whole square dv, which is equal to integration of dx by x. Okay, so this side, write it carefully. This is nothing but 1 by 2 root 2 log of 1 by 2 root 2 log of 1 plus square root of 2v divided by 1 minus square root of 2v. Okay, this, since the coefficient of v is square root of 2, you will get a 1 more square root of 2 here actually. That's why. Otherwise, it is 1 by 2. Okay, which is equal to log x plus k. Now, if you want, you can remove logarithm from both sides also, or this is the answer basically. If I replace v with y by x, this is what you get. Okay, next. X dy minus y dx equal to square root of x square plus y square dx. Okay, now take all x terms to one side and dy terms to other side. You will get dy by dx is square root of x square plus y square plus y by x. Okay, this, if I rewrite, square root of 1 plus y by x whole square plus y by x, which is very clearly seen as homogeneous equation in degree 0. Okay, so same way you will take y by x equal to v, and then bring all the dv terms to one side, v terms and x term to other side. So this is dv by square root of 1 plus v square, which is equal to dx by x. Okay, integrate on both sides. This is a very simple integration. This is nothing but log of v plus square root of 1 plus v square, okay, which is equal to log of x plus k. You can call this log c or log k, okay. So this is nothing but y by x plus square root of 1 plus y by x whole square equal to log cx or kx, okay, or y by x plus square root of 1 plus y by x whole square equal to cx. This is the solution. Simplify further, this will become y plus square root of y square plus x square equal to cx square, okay. Next, x cos of y by x plus y sin of y by x y dx, which is equal to y sin of y by x minus x cos of y by x into x dy. Okay, it just looks complex. Just to separate the terms carefully. What is your dy by dx? That's what you are interested in, correct? So your dy by dx is nothing but x cos y by x plus x y sin y by x into y divided by y sin y by x minus x cos y by x into x. Okay, this is my f of x comma y. If I replace x with this is my dy by dx, okay. Further simplification, basically just to make sure that everything is in y by x terms, okay. So we can clearly see this is a if I cancel x and 1x here, this is also y by x, okay. So everything is in y by x term. So this is a homogeneous equation of degree 0. This is my f of x comma y, okay. F of ax comma ay also e to the power of 0 into f of x comma y. So homogeneous equation of degree 0. Now it is all about just substitution, right? So this is my v plus x dv by dx, which is this value, okay. Now x dv by dx is nothing but this minus v, okay. If I simplify further, this will be x dv by dx is nothing but uh, 2v cos v divided by v sin v minus cos v. Okay, if I take all v terms to one side, x terms to other side, this is what it is. Okay, now carefully do the integration. Integrate on both sides. This is what it is. Okay, if I divide this one, this will become 1 by 2 tan v minus 1 by v. Okay, 1 by 2v basically, okay. So 1 by 2, if I take it common, integration of tan v minus 1 by v dv, which is equal to integration of dx by x. So this is simple, right? Half, this is log secant v, tan v integration is 1 by v is nothing but minus log v, which is equal to log x plus log k. So all logarithms you can take it out, okay. So kx square equal to secant v divided by v, or x by y secant y by x equal to, right, this is what it is. Secant v by v is this value. So c times xy equal to secant y by x, okay. So this is the final solution to the differential equation, okay. Next, x dy by dx minus y plus x sin y by x equal to 0, okay. So dy by dx is nothing but y by x minus sin y by x, which is my f of x comma y. We can clearly see this is the homogeneous equation in degree 0, correct. So same thing, you substitute and bring all the terms like terms same side. So this will become dv divided by minus sin v equal to dx by x. Integrate on both sides, minus integration of cosecant v dv equal to integration of dx by x. Okay, the integration of this one is nothing but log of cosecant v minus cot v, which is equal to minus log x plus k, okay, or x into cosecant v minus cot v equal to constant c. Okay, now you replace v with y by x. This will become x into 1 minus cos y by x. Okay, simplification basically I am doing, which is equal to c times sine of y by x. Okay, or I can just put y by x here, that's also fine. Okay, next, y dx plus x log y by x dy minus 2x dy equal to 0. Okay, so carefully bring terms, uh, move the terms so that you get dy by dx. Dy by dx is y by 2x minus x log y by x, or y by x divided by 2 minus log y by x. Okay, now clearly I can see if I replace x with ax, y with ay, I will still get same. So this is a homogeneous equation in of degree 0. Okay, so same thing, you will take y by x equal to v. All this procedure is exactly same. Okay, bring all the v terms together. So what you will get is 2 minus log v divided by v log v minus v dv equal to dx by x. Okay, integrate on both sides. Okay, you take log v equal to t, so 1 by v dv is dt. Okay, so there is a 1 by v here common actually. So this will become 2 minus t divided by t minus 1 dt equal to, this is, I can rewrite this as 1 by 1 minus t minus 1 dt, which is equal to integration of dx by x. Okay, this is log 1 minus t minus log 1 minus t minus t equal to log of x plus k. Okay, now put together, this will become minus log 1 minus log y by x. Okay, because log v is t basically, right? So log y by x equal to t. So this is what it is, which is equal to k plus log x times, because this is nothing but log y by x. So log x times y by x. This is log y. So log of y by x minus 1 equal to cy. This is the solution to this differential equation. Okay, next. 1 plus e to the power of x by y dx plus e to the power of x by y into 1 minus x by y dy equal to 0. If you look at, okay, each term x by y, x by x by y are very clear, right? So you take this one as x by y equal to v. Okay, this is definitely a homogeneous equation in degree 0, which you can easily prove. Okay, so dy by dx is this value. Okay, now you, okay, you take dx by dy, which is reverse. Okay, because you have everything in terms of x by y, so it is easy to take dx by dy. So dx by dy equal to this value. Okay, x by y equal to v, or x equal to vy. If you differentiate dx by dy equal to v plus y dv by dv by dy, replace it, what you will get is v plus y dv by dy equal to e to the power of v minus into 1 minus v divided by 1 plus e to the power of v. Okay, so bring all the terms one side, you will get y dv by dy equal to this value. Okay, which is this, nothing but integration of 1 plus ev, 1 plus e to the power of v divided by minus v plus e to the power of v dv equal to integration of dx by x. Okay, so let us take v plus e to the power of v as t, then 1 plus e to the power of v into dv equal to dt, which is numerator. So this will become simply minus integration of 1 by t dt, which is equal to integration of dx by x. So minus log t equal to log x plus k, or minus log y by x plus e to the power of y by x equal to k plus log x. If I take all logarithm out, basically consider this as log c. This will become x times y by x plus e to the power of y by x equal to c, or y plus x e to the power of y by x equal to c. This is the solution. Okay, next. Find particular solution satisfying the given solution. Okay, so previously we are finding general solution. In this case, we have to find the particular solution, which means we need to use this information. Okay, y equal to 1 when x equal to 1, right? This information, that is x comma y is 1 comma 1 basically. Use this information to find the constant value, constant k we add, right? So we need to find that value. Okay, so that is a particular solution. So let's do one of them, right? So from this given expression, okay, given equation, dy by dx is nothing but y minus x by y plus x. This is obviously in the form of homogeneous equation of order 0, okay, which is very simple to show, right? Everything we do same, okay, until we find the general solution. Okay, so y by x is v, which means dy by dx is v plus x dv by dy, and which is equal to v minus 1 by v plus 1. Okay, so you take v to the other side. So x dv by dx is nothing but minus v square plus 1 by v plus 1. Okay, now take all the v terms to one side, x term to one side, integrate both sides. Okay, so this is the integration, you need to solve it. That's it, so simple. Okay, so first one is minus integration of v by v square plus 1 dv. So here if I take v square plus 1 as t, then v dv is nothing but dt by 2. Correct? That's how you solve this one. And second part is, this is tan inverse of v. This is log of x. Okay, so putting all the values together, this will become minus of log t, which is nothing but v square plus 1, minus tan inverse of v, which is equal to log of modulus x plus k. Okay, so I wrote it here. t is nothing but v square is nothing but y square by x square. So this is the general solutions, minus of log of y square by x square plus 1 minus tan inverse of y by x, which is equal to k plus log x. Now we have one information which is given, x comma y is 1 comma 1, correct? This is simplified form of above solution. Okay, so you substitute x comma y equal to 1 comma 1. Okay, which means this will become log of square root of 2 plus tan inverse of 1, which is equal to k. So tan inverse of 1 is pi by 4, and this is log of square root of 2. So k is nothing but pi by 4 plus log of square root of 2. So replace that value, you get the particular solutions. Okay, so log of square root of x square plus y square plus tan inverse of y by x equal to pi by 4 plus log of square root of 2. Okay, so this is the particular solution. All the problems in this exercise, we will solve it the same way. Only thing is integrations might differ, but procedure is exactly same. Okay, so here x square dy plus xy plus y square into dx equal to 0. X comma y is 1 comma 1 again. Okay, so dy by dx, if I write it, this will become minus y by x minus y by x whole square. Okay, now again we can clearly see this is the homogeneous equation of degree 0, order 0, correct? So we can prove it here, very simple. Okay, now you take it same, y by x equal to v, or dy by dx equal to v plus x dv by dy, okay, which is equal to minus v by minus v square, minus v by minus v square. Okay, so if I take all v terms to one side, this is what it is, dv by 2v plus v square equal to dx by x. Okay, integrate on both sides. Okay, use the partial fraction method. This I can write it as v into v plus 2, v into v plus 2, 1 by v into v plus 2. This is nothing but half into 1 by v minus 1 by 2 plus v. Okay, now replace this one. Okay, so this will become minus half into integration of 1 by v minus 1 by 2 plus v dv, which is equal to integration of dx by x. Okay, so this is nothing but, this is simple, minus half into log of v by 2 plus v. This is log v minus log 2 plus v. If I combine them, this is what it is, which is equal to log of x. Okay, this is minus k is the constant, minus r plus k or log k, whatever you can write it. Okay, so my constant c is nothing but log of y by x by 2 plus y by x plus 2 log x. Okay, now you substitute x comma y as 1 comma 1. So this will become 1 by 3 log of, okay, 1 by 3 plus 2 log 1, which is 0 anyway. Okay, now, oh, sorry. Okay, we didn't substitute, sorry, here. Okay, if I remove the logarithm, if you call this as log c, c is nothing but y x square by 2x plus y. Okay, now what is c? I need to substitute, actually I did not do. Okay, x equal to y, y equal to x equal to 1, y equal to 1. If I substitute, this will become 1 by 3. c is 1 by 3. So the answer is log of y x square by 2x plus y equal to 1 by 3. This is the answer. Okay, I did not complete this, that's what you need to write. Okay, next. X sin square y by x minus y dx plus x dy equal to 0, y equal to pi by 4 when x equal to 1. Okay, so that means x comma y is 1 comma pi by 4. Okay, so dy by dx is written here, x sin square y by x minus y by minus x, which is nothing but y by x minus sin square y by x. This is again homogeneous equation because you have y by x term everywhere of degree order 0. Okay, so you will take y by x as v, and then x dv by dx is nothing but minus sine square v. Okay, so if I take all the terms together, minus dv by sine square v equal to dx by x, integrate on both sides, this is what you get, minus integration of cosecant square v dv equal to integration of dx by x. Okay, so the solution is cot v equal to log of x plus k. Now you substitute these values, right? Simple. Cot y by x equal to log of x plus k, or cot pi by 4 equal to log of 1 plus k, or this is 1, this is 0, so k is equal to 1. So my particular solution is cot of y by x equal to log x plus 1. This is my particular solution. Okay, next. dy by dx minus y by x plus cosecant y by x equal to 0. This is straightforward. We can see that this is in the form of homogeneous equation of order 0, right? So we just need to substitute the particular solution. That's it. Okay, so you can do it yourself. This is quite straightforward. You will get minus integration of sin v dv equal to integration of dx by x, which means cos v equal to log x plus k. You substitute this value and find the particular solution. Okay, So that is cos 0 equal to log 1 plus k or k equal to 1, which is nothing but particular solution is cos of y by x equal to log x plus 1, which is equal to log ex. I can write, right? Log of ex. I can write it as log e. Okay. Next. 2xy plus y square minus 2x square into dy by dx equal to 0. X comma y is 1 comma 2. Okay. Now again, you take dy by dx, which is nothing but 2xy plus y square by 2x square, which is clearly homogeneous equation of order 0. We can write it in this y by x plus half of y by x whole square. Okay, so same thing you will do, exactly same thing. So when you get the integration, it will become integration of 2 dv by v square equal to integration of dx by x. Okay, this part are all same. Okay, exactly same. Okay, now this is nothing but minus 2 by v, which is equal to log of x plus k. Now I need to substitute these values for the particular solution. So minus 2 x by y equal to log of x plus k. If I substitute, this will become minus 2 into 1 by 2 equal to log of 1, which is 0 plus k. So k is minus 1. So my particular solution is log of x plus 2 times x by y equal to 1. Okay, next. Homogeneous equation of the form dx by dy equal to h of x by y can be solved by making substitution. So here it is x by y, right? So you take x by y equal to v, x by y equal to v. So which means x equal to yv. Okay, so C is the correct answer. Okay, next. Which of the following is a homogeneous differential equation? Okay, so if you see this 4 options, okay, which one you can write in the form of x by y or y by x, or you substitute you substitute x equal to ax, y equal to ay, and then find out what is the final solution. Okay, so if you do one by one, you will know option D is the correct. Okay, y square dx plus x square minus xy minus y square dy equal to 0. If you see everywhere you have power 2 actually. Power 2 here, power 2 here, xy combined power is 2, y square is 2. So this is obviously the correct answer. Here you have power 3, power 2. So it cannot be homogeneous equation. Okay, same thing here. Power 2, you have power 3 here. Not possible. Power 1 here. Okay. Yeah, but you have a constant term here, power 0, right? This is power 0, and power 1. So this is not homogeneous. Okay. So option D is correct answer. Okay, next. Okay. Yeah, let's learn one more trick to solve the differential equation. Okay. What will do? First order linear differential equation is one that can be written in the form of dy by dx plus p of x into y, which is equal to q of x. Okay, note down this one. Okay, carefully. Okay, so if it is in this form, where p and q are constants or functions of x only, okay, no combined, no x comma y. If this is in this form, then integrating factor you will find. The key idea is to multiply the equation by a special function called integrating factor if. If is e to the power of integration of p of x dx. P of x is here. Okay. Now, once you get this one integrating factor, the solution of this differential equation is, okay, if you multiply both sides, this is what you get basically. Okay, very easy to prove. Okay, solution of the differential equation is y into integrating factor equal to integration of q of x into integrating factor dx plus constant. Okay, which means y is nothing but this whole. Okay, or you can solve this one, you will get this anyway in this form. Okay, y you will get in this form. Okay, so if you can write a equation in this form, okay, first order linear differential equation, if you write in this form, then this is the solution of the integration. Okay, just be careful. It is possible that it can be dx by dy. In that case, you will have p of y into x, which is equal to q of y. Okay, integrating factor will become e to the power of integration of p of y dy. Then here it will be x into integrating factor equal to integration of q of y into integrating factor dy plus constant. Okay, hope you understand if x and y are interchanged. Okay, so this is one way of solving the differential equations. Okay, so let's do some example, then you will understand very easily. Okay, general solution of x into dy by dx plus 2y equal to x square. Okay, now I write it like this. If I make it dy by dx plus 2 by x into y equal to x, so 2 by x is my p of x, correct, into y. P is 2 by x, Q is x. Okay. Now my integrating factor is e to the power of integration of P dx, which is e to the power of integration of 2 by x dx, which is e to the power of 2 log x, or e to the power of log x square, or this is nothing but x square. Okay. My integrating factor is x square. Now my solution is y into x square equal to integration of x, q of x is x into x square dx, which is x cube. So the solution is x to the power of 4 by 4 plus constant. Okay. Now y is equal to x square by 4 plus constant c into x to the power of minus 2. This is the solution of the general solution of the differential equation. If you substitute x comma y one of the pair values, you will get the constant c. Then it will become a particular solution. Okay. So this is how you solve this. Let's do exercise 9.5 based on this last concept which we have learned. Okay. So these are the various methods of solving the differential equations. The last method is the one which we'll do exercise now. Okay. Find the general solution of a differential equation. Okay. dy by dx plus 2y equal to sin x. Now this is in the form of dy by dx plus p of x into y equal to q of x. Correct. So my p of x is 2, q of x is sin x. Okay. This is compared with this standard formula, right? My p of x is 2, q of x is sin x. Now what is the integrating factor? Integrating factor is integration of p dx, that is integration of 2 dx. Okay. E to the power of e to the power of integration of 2 dx. Okay, which is nothing but e to the power of 2x. Okay. Now this is my integrating factor. So general solution of any equation in this form is y into integrating factor equal to integration of integrating factor into q dx, which means y into 2 to the power of e to the power of 2x equal to integration of e to the power of 2x into sin x dx. Okay, now you just solve this one. This is simple, correct? So only thing is this you need to apply product rule, and you need to apply twice because this involves repetitive function, periodic functions, right? Okay. So your f of x is sin x, and g of x is e to the power of 2x, because I late, e is last actually. Okay. So this is how you do it. Now y into e to the power of 2x equal to sin x, f of x is sin x into integration of e to the power of 2x, which is e to the power of 2x by 2, minus integration of differentiation of sin x, which is cos x, into integration of e to the power of 2x, which is e to the power of 2x by 2 dx. Okay. Now you need to do integration of this one again using product rule. Okay. So apply product rule again. So far it is y into e to the power of 2x equal to sin x into e to the power of 2x by 2 minus, okay, minus half I am taking out, so half into whole. Okay. Cos x as is cos of x into e to the power of 2x by integration, which is e to the power of 2x by 2, plus minus into minus will become plus, integration of differentiation of cos x is minus sin x, so minus into minus has become plus here, into e to the power of 2x by 2 dx. Okay. Now this is your same value, right? You have started with this value, which is I, correct? So that is nothing but your y into e to the power of 2x. Okay. So if we replace it and simplify it, you will get your answer, which is 5 by 4 into y into e to the power of 2x equal to sin x into e to the power of 2x by 2 minus 1 by 4 into cos x into e to the power of 2x. So plus constant will be there. So if you cancel e to the power of 2x basically, okay, plus constant is there. If you cancel e to the power of 2x, this will become, looks like 5y equal to 2 sin x minus cos x plus k into e to the power of minus 2x. Okay. This is what it will, general solution. Okay. Next. dy by dx plus 3y equal to e to the power of minus 2x. Okay, here your p of x is 3, and q of x is e to the power of minus 2x. Okay, so how do you do this now? If integrating factor is nothing but e to the power of integration of 3 dx, which is e to the power of 3x. Okay, now solution is y into integration factor equal to integration of if into q dx. Okay, so y into e to the power of 3x equal to integration of e to the power of 3x into e to the power of minus 2x dx, which is nothing but e to the power of x. This is correct. So integration of e to the power of x is e to the power of x plus k. Okay. So now you got your solution already. Now if you want to, you can simplify this, or you can write it like this: y into e to the power of 3x equal to e to the power of x plus k is the general solution, or you can write it in other way: y equal to e to the power of minus 2x plus k into e to the power of minus 3x. Okay, if you want to write in terms of y equal to. Okay, so this is the general solution. dy by dx plus y by x equal to x square. Okay, now if I compare, my p of x is 1 by x, q is x square. So integrating factor is nothing but e to the power of integration of 1 by x dx, which is e to the power of log x. This you can call it as x. Okay, so y into x, the solution is y into x equal to integration of x into x square dx, or this is integration of x cube dx, that is equal to x to the power of 4 by 4 plus constant k. Okay, now you can either leave it like this answer, or you can call it y equal to x cube by 4, x cube by 4 plus k by x. Okay, next, it is better always write in terms of y equal to. Okay, next, dy by dx plus secant x y, secant x into y equal to tan x, where x is between 0 to pi by 2. Okay, so compare with dy by dx plus py equal to q, which is the standard form. Okay, p of x equal to secant x, q of x equal to tan x. Now integrating factor is nothing but e to the power of integration of secant x dx, which is e to the power of log of secant x plus tan x. Okay, so this is nothing but secant x plus tan x. This is my integrating factor. So my solution is y into secant x plus tan x equal to integration of secant x plus tan x into tan x dx. Now you take this inside, this is simple. Integration of secant x tan x plus secant square x minus 1. Okay, equal minus, yeah, tan x I am writing it as secant square x minus 1. Okay, that's why it came minus 1 dx. Okay, so integration of secant x tan x is secant x, integration of secant square x is tan x, integration of minus 1 is minus x. So my answer is secant x plus tan x minus x plus k. Okay, and the solution is obviously y into secant x plus tan x equal to secant x plus tan x minus x plus k. Okay, cos square x into dy by dx plus y equal to tan x. Okay, first thing is write in this standard form dy by dx plus py plus equal to q. Okay, so this will become dy by dx plus secant square x into y equal to secant square x into tan x. Okay, now my p, compare with the standard form, my p of x is secant square x, q of x is secant square x tan x. Integrating factor is e to the power of integration of secant square x dx, which is e to the power of tan x. Solution is y into integrating factor, that is y into e to the power of tan x equal to integration of secant square x into tan x into e to the power of tan x dx. Okay, now here you take t as tan x, then this integration will become integration of t into e to the power of t dt. Now you apply product rule, you get t into integration of e to the power of t dt minus integration of e to the power of t dt. Okay, so this we know already, this is e to the power of t only, correct? So your solution is y into e to the power of tan x equal to e to the power of t into t minus 1 plus k, or e to the power of tan x into tan x minus 1 plus k. Okay, now if you want, you can take this common and write it y equal to, so you can cancel e to the power of tan x. So y is equal to tan x minus 1 plus k by e to the power of tan x. That is also way of representing the solution. Okay, next. X into dy by dx plus 2y equal to x square log x. Okay, this is in the standard form if I divide with x basically. So dy by dx plus 2 by xy equal to x log x. Okay, p is equal to 2 by x, q is x log x, integrating factor is e to the power of integration of 2 by x dx, which is e to the power of log x square, or x square is the integrating factor. Okay, now solution is y into x square equal to integration of x square into x log x, which is x cube into log x dx. Okay, apply product rule. I late log will come before algebra, so this is my f of x, this is my g of x. Okay, so f of x is log x, g of x is x cube. Applying product rule, y into x square equal to log x into x to the power of 4 by 4 minus integration of 1 by x into x to the power of 4 by 4 dx. This is nothing but x to the power of 4 by 4 into log x minus x to the power of 4 by 16 plus k, or you divide x square on both sides, you will get y is equal to x square by 4 log x minus x square by 16 plus k by x square. Okay, next. X log x dy by dx plus y equal to 2 by x log x. Okay, now again you need to put it in standard form first. So dy by dx plus y by x log x equal to 2 by x square. Okay, compare with the standard form, p of x is 1 by x log x, q of x is 2 by x square, integrating factor is e to the power of integration of 1 by x log x dx, which is, if I take log x as t, this will become dx by x is dt, so this will become log of log x, answer is, okay, log of e to the power of log x, which is equal to log x. Okay, now my solution is this general solution. So y into log of x equal to integration of log x into 2 by x square dx. Okay, so apply the product rule again. Okay, f of x is log x, g of x is x to the power of minus 2. Okay, y into log x equal to 2 times. Okay, 2 is there, right? 2 times log x into minus 1 by x minus integration of minus 1 by x square dx. So this is nothing but 2 times minus log x by x minus 1 by x plus k. Okay, so you want to call y equal to, so y is equal to minus 2 by x minus 2 by x. Okay, if I take minus out, log x cancel, so 1. Okay, 1 by x also I took out. Okay, so 1 plus 1 by log x into plus k by log x. This is the general solution. Next, 1 plus x square dy plus 2xy dx equal to cot x dx. X is not equal to 0. First you should write in standard form, which is dy by dx. So for that you divide everything with dx, so you will get dy by dx here, and then divide it by 1 plus x square. So your dy by dx is nothing but plus 2xy divided by 1 plus x square equal to cot x 1 plus x square. Now this is in the standard form, correct? So my p of x is 2x by 1 plus x square, q is cot x by 1 plus x square. So my integrating factor is e to the power of integration of 2x by 1 plus x square dx. If I take 1 plus x square as t, 2x dx is dt. So this is log of 1 plus x square, e to the power of log of 1 plus x square, or integrating factor is 1 plus x square. Okay, now solution is y into 1 plus x square equal to integration of 1 plus x square into cot x by 1 plus x square dx. This gets cancelled, so I am left with integration of cot x dx. Correct? So that is simple. Integration of cot x dx is nothing but log of sin x plus k. Okay, log of sin x plus k. So or minus log of cosecant x, but this is a better way of writing because you don't want to put the negative terms, right? So y is equal to log of sin x divided by 1 plus x square plus k by 1 plus x square. This is the solution. Next. X dy by dx plus y minus x plus xy cot x equal to 0. X is not equal to 0. Again, put it in the standard form. So this is dy by dx plus y into 1 plus x cot x by x equal to 1. So my you compare with the standard form, p of x equal to 1 plus cot x, 1 plus x cot x by x, and q is 1. So integrating factor is e to the power of integration of 1 plus x cot x by x dx. Okay. Now let's do this integration. Integration of 1 plus x cot x by x is nothing but integration of 1 by x plus cot x dx, which is nothing but log x plus log of sin x. Okay. Now once you know all these things, okay, your integrating factor is e to the power of log of x sin x, which is x sin x. Okay. So your general solution is this one. So y into x sin x equal to integration of x sin x dx. Okay, because q is 1 anyway. Okay. Now this you can done by product rule, by applying product rule. So x into y into x sin x equal to minus x cos x plus integration of cos x dx, which is anyway sin x. So x in y into x sin x equal to minus x cos x plus sin x plus k. Okay, or you can write it as y equal to 1 by x minus cot x plus k by x sin x. Okay, this is the general solution. Next, next, x plus y into dy by dx equal to 1. Okay, so this is, if I put it across, it is dx by dy equal to x plus y, correct? Dx by dy equal to x plus y, which is simple. Okay, now only thing is, remember, normally we are doing dy by dx, but this time we are doing dx by dy. So carefully write the formula and then solve it. Okay, this is very simple. So what we should compare is, compare with dx by dy plus px, p of y into px into x equal to q of y. Okay, so if you compare, p is nothing but minus 1, q is nothing but y, correct? So my integrating factor is e to the power of integration of minus 1 dy, which is e to the power of minus 5. So solution is x into integration factor, okay, which is equal to integration of integration factor to q dy. Okay, careful, dy here. Okay, so that is x into e to the power of y equal to integration of e to the power of minus y into y dy. Now this you need to apply product rule. Okay, so if you apply product rule, this will become y into e to the power of minus 5 by minus 1 plus, how pluses come? because integration of e to the power of minus y is integration of e to the power of minus y minus 1. So this minus and minus become plus, and we are left with integration of e to the power of minus y dy. Okay, so simply this is x into e to the power of minus y equal to minus y into e to the power of minus y minus e to the power of minus y plus k. Okay, or I can simplify this as x equal to minus y minus 1 plus k by e to the power of minus y. Okay, so or you can also call it x plus y plus 1 equal to k into e to the power of y. Okay, next, y dx plus x minus y square dy equal to 0. So dx by dy equal to y minus x by y, which implies dx by dy plus x by y equal to y. Okay, so now what is my p? Careful, this is dx by dy. So my p of y is 1 by y, correct? And q is y. So integration factor is e to the power of integration of 1 by y dy, which is y. Okay, solution is x into y, which is equal to integration of y into y dy, which is y square. So solution is y cube by 3 plus k, which is nothing but x equal to y square by 3 plus k by y. Okay, next, x plus 3y square into dy by dx equal to y. Okay, or dx by dy equal to 1 by y x plus 3y, or dx by dy minus x by y equal to 3y. Here my p is minus 1 by y, correct, and q is 3y. So integration factor is e to the power of integration of minus 1 by y dy, which is 1 by y. Okay, so solution is x into 1 by y equal to integration of 3y into 1 by y dy, which is 3y plus k. Okay, so final solution is x equal to 3y square plus ky. Okay, this is how you should do all these problems. Okay, most of the problems are similarly exactly the same way you will do. Only thing is you find out whether it is dy by dx or dx by dy. Okay, so here your p of x is tan x, 2 tan x, and q of x is sin x. Okay, so you will solve in the same way as others, exactly same way, no different. Okay, you can do it yourself. Okay, only thing is difference here is we need to find a particular solution in this case. So they gave a x comma y value. Okay, y equal to 0 when x is pi by 3, which means x comma y is pi by 3 comma 0. So once you get your final solution here, y equal to cos x plus k cos square x, substitute y equal to 0 when x is pi by 3. So 0 equal to cos pi by 3 plus k times cos square pi by 3, which means k is minus 2. If you know k is minus 2, this particular solution is y equal to cos x minus 2 cos square x. Okay, next. Again, we are finding particular solution, but procedure is exactly same until the last step where you, after that you substitute this value. Okay, so dy by dx plus 2x by 1 plus x square equal to 1 by 1 plus x square whole square. So my p is 2x by 1 plus x square, q is 1 plus x square whole square. Integration factor is e to the power of log 1 plus x square, which is 1 plus x square. Okay, solution is y into 1 plus x square equal to integration of 1 plus x square divided by 1 plus x square whole square dx, which is nothing but 1 by 1 plus x square dx. Okay, that is tan inverse x plus k. So my particular solution now is, okay, substitute y equal to 0 and x equal to 1. Okay, so this will become 0 equal to tan inverse 1 plus k, which is pi by 4 plus k, or k is minus pi by 4. So my particular solution is y into 1 plus x square equal to tan inverse x minus pi by 4. Next, dy by dx minus 3y cot x equal to sin 2x, and value is given for the for finding constant value. So dy by dx minus 3y cot x equal to sin 2x. My p is nothing but minus 3 cot x, q is sin 2x. Okay, integration factor is e to the power of integration of minus 3 cot x dx, which is nothing but 1 by sin cube x or cosecant cube x. Okay, now solution is y into cosecant cube x equal to integration of cosecant cube x into sin 2x dx. Okay, so here I get my sin x. So this I can write it as integration of 2 times cos x cosecant x dx. Okay, because this is sorry, this is not cos, this is cot x. Okay, cot x cosecant x. Okay, so which means it is minus 2 cosecant x plus k. Okay, minus 2 cosecant x plus k. Now you substitute the value. So y is equal to minus 2 sine square x plus k sine cube x. Okay, or uh, y equal to 2 when x equal to pi by 2. Substitute the value. K is 4. So my solution is y equal to minus 2 sine square x plus 4 sine cube x. Okay, so this is the solution. Next. Find the equation of the curve passing through the origin given that the slope of the tangent to the curve at any point x comma y is equal to the sum of coordinates of the points. Okay, so these are written problems which you can do it very easily. Given that slope of curve is dy by dx, which is equal to x plus y. Okay, which means dy by dx minus y equal to x. This is in the form of this one, right? Your p is minus 1 and q is x. So integration factor is e to the power of integration of minus 1 dx, which is e to the power of minus x. Solution is y into e to the power of minus x equal to integration of e to the power of minus x into x dx. Apply the product rule, integration by product rule. So what you will get is, yeah, this one, y plus x plus 1 equal to k times e to the power of x. Okay. Now, if you want particular solution, they will give information. It is passing through some uh, coordinates. Okay, so this is my particular solution. It is given that curve is passing through 0 comma 0. Okay, it is given that passing through the origin. Okay, so if I substitute the values x equal to 0, y equal to 0, I'll get k equal to 1. So my particular solution is, curve equation is, y plus x plus 1 equal to e to the power of x. This is also exactly same. It is all about writing the equation first. Equation of a curve passing through the point 0 comma 2, given that the sum of coordinates at any point on the curve exceeds the magnitude of slope of tangent to the curve at that point by 5. Okay, so carefully write. First is slope of the tangent, which is dy by dx. Sum of coordinates is x plus 5. Okay, so this x plus 5, x plus y is equal to dy by dx plus 5. This exceeds by 5. Okay, with slope of tangent, which means my dy by dx minus y equal to x minus 5. Now it's clear. Comparing p is minus 1, q is x minus 5. Integration factor is e to the power of integration of minus 1 dx, which is e to the power of minus x. Solution is y into e to the power of minus x equal to integration of e to the power of minus x into x minus 5 dx. Okay, integration by product rule you will do. Okay, so you will get, this is your general solution. Okay, now this is passing through 0 comma 2, so you substitute x equal to 0. So all the e to the power of things will become 1 basically. Okay, and 2 is equal to 5 minus 1 plus k, which means k is minus 2. K is minus 2. So my solution of the equation, curve equation, is y equal to minus of x minus 5 minus 1 minus 2 into e to the power of x. Okay, this is the solution equation. I mean, equation of the curve. Okay, you can write it alternatively in this way. Next, the integrating factor of x dy by dx minus y equal to 2x square is, okay, options are given. So first is, write it in the standard form, dy by dx minus y by x equal to 2x square. Okay, actually 2x, it will be 2x actually. Okay, but it doesn't matter because integration factor comes only from this one. Okay, so my p is, compared with this value, my p is minus 1 by x. So integration factor is e to the power of integration of minus 1 by x dx, which is e to the power of minus log x, which is 1 by x. Okay, so my integration factor is 1 by x. That is, C is the right answer. Okay, next, integrating factor of this one. Okay, so now this one you will write in dx by dy form. Dx by dy plus yx by 1 minus y square equal to ay by 1 minus y square. Compare it with this. Your p is nothing but y by 1 minus y square. So integration factor is e to the power of integration of y by 1 minus y square dy. This is nothing but e to the power of minus half log t, or 1 by square root of t. Okay, or 1 by square root of 1 minus y square. Okay, this is your integration factor, which is in this one it is D is the option. Okay, next. Yeah, that's all. Now let's do some miscellaneous exercise. Okay, combining all the things which we have learned in this chapter. Okay, so let's do it. Indicate the order and degree of the following differential equations, which is simple. Okay, So here highest order is this one. Okay, d square y by dx square. Okay, so its order is 2. Degree is, this is power of this one is 1, so degree is 1. D to the power of 4y by dx power 4 minus sine of d cube y by dx cube, which is equal to 0. Highest order is this one, so which means order is 4. Degree doesn't exist because this has a differential uh, term in the sign, inside sign. Okay, it is not polynomial. Sorry, polynomial. Okay, spelling mistake. Okay, now in this one, the order is 1, degree is 3. Okay, order is 1, degree is 3. Verify the given function is the solution of corresponding differential equation or not. Okay, so this is the xy equal to a e to the power of x plus b e to the power of minus x plus x square, and this is a differential equation. Okay, so we just need to verify it, that's all. Okay, so this is xy given solution. Differentiate y plus x dy by dx equal to a e to the power of x minus b e to the power of minus x plus 2x. Differentiate again, this is what you get. Okay, and here you get back the same thing actually, right? So if you simplify this, you get again same thing what is mentioned here, differential equation. So this is the indeed a solution of the differential equation. Okay, y equal to e to the power of x into a cos x plus b sin x, and d square y by dx square minus 2 dy by dx plus 2y equal to 0. So take this one, differentiate. Okay, this is the differentiation. Now differentiate again, or first simplify and then differentiate again. Okay, so you will get d square y by dx square equal to this one. You rearrange this, okay, in such a way that you get actually d square y by dx square is nothing but 2 dy by dx minus 2y. Okay, which is exactly same what is given here if you bring everything to the same side. Okay, next. Verify the given function is a solution of corresponding differential equation. Okay, third one, y equal to x sin 3x and d square y by dx square plus 9y minus 6 cos 3x equal to 0. So you need to differentiate this 2 times, correct? First time, you get dy by dx equal to sin 3x plus 3x cos x. Second time, d square y by dx square equal to 3 cos x plus 3 cos 3x minus 9x sin 3x. Okay, which means if I simplify, I get d square y by dx square plus 9y minus 6 cos 3x equal to 0, because this is y, correct? This is y. Okay, same way you can do this one also. You can do it yourself. Cross, if you can't solve it, you can just refer to this one. Okay, next. Prove that x square minus y square equal to c times x square plus y square whole square is the general solution of the differential equation which is given here. Okay, so first take this one and then differentiate and then get back to the other one, right? So or solve it, you'll get back this one. Okay, so let's do other way. X cube minus 3xy square dx equal to y cube minus 3x square by dy. Take the terms properly. Dy by dx equal to x cube minus 3xy square divided by y cube minus 3x square y, which if I put it in homogeneous form, so you can clearly see this is a homogeneous equation of order 0, correct? So you can take y by x equal to b, okay, which means y equal to bx, or dy by dx is x dv by dx plus v. Okay, so which is equal to, if I substitute y by x as v, this will become 1 by v cube, because x cube by y cube, 1 minus 3v square divided by 1 minus 3 by v square. Okay, now you simplify, this is what it is. Take all the v terms to one side. Okay, what you will get is v cube minus 3v divided by 1 minus v to the power of 4 into dv equal to dx by x. Now integrate on both sides. Okay, or use partial fractions basically for this integration. Okay, so v cube minus 3v by 1 minus v to the power of 4, you can write it as partial fractions in this way. Solve it, you get ABC. ABC is nothing but A is minus half, B is half, C is minus 2, D is 0. Okay, so this is your partial fraction. Okay, now integrate on both sides. Okay, what you will get is half log 1 minus v square minus log 1 plus v square equal to log x plus log c. I'm taking the constant as log c. Okay, if you see how this has come, if I take half common, this is log of 1 plus v, log of 1 plus v minus log of 1 by b, correct? So this is what it is. Okay, so square root of 1 minus v square by 1 plus v square equal to cx. I can take this one as cx common, and this one is square root of 1 minus v square, right? Log of square root of 1 minus v square minus log of 1 plus v square, so it will be go division. Okay, now you substitute the values. V is nothing but y square by y by x basically. So 1 and square it. What you will get is 1 minus y square by x square equal to c times x square. Constant is a constant. It can be c square, c cube. It doesn't matter actually. X square into 1 plus y square by x square whole square. So this is what you got, right? If you put it in right format, you get this. Simplified. Okay. So indeed, this is a solution of the given differential equation. Find the general solution of the differential equation given here. Okay, so you can separate easily y terms and x terms, so which is very simple. dy by dx is minus square root of 1 minus y square by 1 minus x square. So dy by square root of 1 minus y square equal to minus dx by square root of 1 minus x square. Integrate on both sides. Okay, you get sine inverse of y, which is equal to minus sine inverse of x plus k, or sine inverse of y plus sine inverse of x equal to k. This is the general solution. Okay. Show the general solution of differential equation given here is x plus y plus 1 equal to a times 1 minus x minus y minus 2xy, where is a parameter. Okay, so you take this one, you can easily split into y and x terms, right? So this is simple. So this will become dy by y square plus y plus 1, sorry, this is y square plus y plus 1 plus dx by x square plus x plus 1, which is equal to 0. Integrate on both sides. Okay, this is what it is. I can write this denominator as y plus half whole square plus 3 by 4 and x plus half whole square plus 3 by 4. So this is in this form, which is the integration is 1 by a tan inverse of x by a. Substitute it. 1 by square root of 3 by 2 tan inverse of y plus half by 3 square root of 3 by 2 plus same thing here with x. Okay, now tan inverse of a plus tan inverse of b, okay, is nothing but tan inverse of a plus b by 1 minus ab. So use this formula. So to summation of these two, okay, this will become tan inverse of 2y plus 2x plus 2. If I add these two, that's what I get, divided by square root of 3 into 1 minus 2y plus 1 into 2x plus 1 by 3. This is equal to, I am calling the other side constant as tan inverse of c, just to make sure that tan inverse gets cancelled. Correct? So this is my final equation, right? Now simplify. That's all we need is simplification. If I take this denominator to the other side, this is what it is. Okay. Now you look at 2, you can cancel, and c by square root of 3, I can call it another constant a. Okay. So I am left with x plus y plus 1, which is equal to a times 1 minus 2xy minus y minus x, which is same, right? So we just proved that this is a differential equation, this is a solution. Next. Okay, find the equation of the curve passing through the point whose differential equation is sin x cos y dx plus cos x sin y dy equal to 0. Okay, so this is also we can easily split into x and y terms separated. Okay, right? So tan x dx equal to minus tan y dy if you separate the terms into x and y. Okay, now this is simple, right? Integrate on both sides. You get minus log secant, log secant x equal to minus log secant y plus log k, or log of secant x into secant y equal to log k, or secant x into secant y equal to k. Now just substitute this. It is passing through this point 0 comma pi by 4. So secant 0 into secant pi by 4 equal to k, or k is square root of 2. Now the equation is secant x into secant y equal to square root of 2. Okay, next. Find the particular solution of the differential equation 1 plus e to the power of 2x plus dy plus 1 plus y square into e to the power of x dx equals 0, given that y equal to 1 when x equal to 0. Okay. So this we know how to solve actually. You can split the x and y terms easily, separate dy by 1 plus y square plus ex dx by 1 plus e to the power of 2x equal to 0. Okay. Just take e to the power of x as t. So ex dx is dt, and this will become 1 plus t square. Correct. So now integrate on both sides. What you will get is this. Here if I substitute e to the power of x as t, okay, this integration is tan inverse of y plus integration of dt by 1 plus t square. which is equal to 0. So tan inverse of y plus tan inverse of t, which is equal to tan inverse of y plus tan inverse of e to the power of x, which is equal to k. Okay. So now substitute y equal to 1 when x equal to 0. So what I'll get is k is pi by 2. So my particular solution is tan inverse of y plus tan inverse of e to the power of x equal to pi by 2. Okay. Yeah, this is an interesting question actually. Y into e to the power of x by y dx equal to x into e to the power of x by y plus y square dy, and y is not equal to 0. Okay. So here x by y are mixed actually. So you cannot really separate them easily. Okay. And if you simplify or if you basically rearrange this equation, okay, what you will get is dx by dy equal to x to the power of e to the power of x by y plus y square by y into e to the power of x by y. We can clearly see that this is not a homogeneous equation, correct? Or x by y plus y by e to the power of x by y. This is not a homogeneous equation, correct? Because there is only y term extra. But still, you can actually solve this by taking v equal to x by y. Okay, how? Just take it v equal to x by y, x equal to vy, okay, or dx by dy equal to y dv by dy plus v. Correct. So this is equal to v plus y by ev, v plus y by ev, okay, which is equal to y dv by dy equal to y e to the power of minus v, okay, or e to the power of v dv, e to the power of e v dv equal to dy, right? So you got all the terms separated, correct, easily. Now you can integrate this one. Okay, so it's not that every time you find such thing you take v equal to x by y or v equal to y by x, you can solve this, but this particular problem you can solve actually. Okay, integrate on both sides, you get integration of e to the power of v dv equal to integration of dy, which is e to the power of v equal to y plus k, or e to the power of x by y equal to y plus k is the solution. Okay, next. Find a particular solution of the differential equation. Yeah, this looks easy actually. You can solve it yourself. Okay. Dy by dx equal to minus x minus y minus 1 divided by x minus y plus 1. If you rearrange this, this is what you get. Okay. Now this is simple. You take x minus y as some t for simplification actually. So x minus y is t. So 1 minus dy by dx equal to dt by dx. Okay. Now dt by dx equal to 1 minus dy by dx. So minus is already so it will become plus t minus 1 by t plus 1. Okay. That means if I simplify this one, okay, if I simplify this one, I'll get t plus 1 by t into dt one side equal to 2 dx. Okay. That means 1 plus 1 by t dt equal to 2 dx. Now integrate on both sides. Okay. Now you will get the solution t plus log t equal to 2x plus k, which means x minus y plus log x minus y equal to 2x plus k. Now you substitute the values y equal to minus 1, x equal to 0. What you will get is k equal to 1. Okay. Do it carefully. You'll get k equal to 1. So your particular solution is either this or log of x minus y equal to x plus y plus 1. Okay. Next. Solve the differential equation given here. Okay. So you can clearly see x terms, y terms splitted properly. But if you write dy by dx, what you will get is dy by dx plus y by square root of x equal to e to the power of minus 2 square root of x by square root of x. Now this is in the form of dy by dx plus y py equal to q. P of x into y equal to q of x, correct? So your p is 1 by square root of x, q is e to the power of minus 2 square root of x by square root of x. Now integrating factor is nothing but e to the power of integration of p dx, which is this e to the power of 2 square root of x. Solution is y into e to the power of 2 square root of x equal to integration of e to the power of 2 square root of x into e to the power of minus 2 square root of x, which will get cancelled by square root of x dx. So this is nothing but integration of 1 by square root of x dx, right? This two gets cancelled. Now simple, this is nothing but 2 square root of x plus k, right? So e to the power of 2 square root of x into y equal to 2 square root of x plus k is the general solution. Next. Okay, now this one is again very easy actually. It is in the form of, you can do it yourself, dy by dx plus P of x into y equal to Q of x. So P is cot x, Q is 4x cosecant x. So you can do it yourself actually. If you get wrong answer, then just refer to this one. Okay, this is straightforward. And once you get the general solution, substitute x equal to pi by 2, y equal to 0. You will get your k value, constant value, and then substitute that. Okay. This is also very similar actually. Nothing special as such. Okay. X plus 1 equal to dy by dx equal to 2 e to the power of minus 5 minus 1. Okay. So which I am writing it as 2 minus e to the power of 5 because e to the power of minus 5 I am writing it as 1 by e to the power of y and then taking LCM. So e to the power of y 2 minus e to the power of y. Okay. Now I can split my y terms and x terms separately. So this is nothing but e to the power of y divided by 2 minus e to the power of y dy, which is equal to dx by dx. Okay. Integrate on both sides. Okay. And you take e to the power of y as t, then you will get this 1 by 2 minus t dt. And here it is integration of dx by x plus 1. Okay. So this solution is minus log 2 minus t equal to log of x plus 1 minus log k. I'm just taking as minus log k. Okay. So this is nothing but k is equal to x plus 1 into 2 minus t. Okay. If I remove all the logarithms, this is what I get. Or x plus 1 into 2 minus e to the power of y equal to k is the general solution. Substitute these values. Okay. You get k equal to 1. So my particular solution is x plus 1 into 2 minus e to the power of y equal to 1. Next. Okay. General solution of this one. Yeah. You can do it yourself. Y minus dx minus x minus dy divided by y equal to 0. So it is nothing but dx by x equal to dy by y. If I rearrange, this is log x equal to log y plus constant. Correct? Log x equal to log y plus log k, or x equal to ky, or you can call it y equal to cx. Anything is okay. Okay. In this one, c y equal to cx is there. So this is the right option. Okay. General solution of differential equation. Here we know that solution is p1. Sorry, integration factor, that is e to the power of integration of p1 dy into y equal to integration of, correct, sorry, x, this is dx by dy. So x into integration factor, which is e to the power of integration of p1 dy, which is equal to integration of q1 into differential factor, which is e integration e to the power of integration of p1 dy and whole dy, which is plus c. Okay. So this is the answer. Okay. Carefully choose. It is dx by dy. Okay. Next. General solution of the differential equation. Yeah, you can solve it yourself. Dy by dx plus y equal to minus 2x by e to the power of x. This is the equation actually. If you simplify it, dy by dx, this is what you get. This is in the form of dy by dx plus p into p of x into y equal to q of x. So my p of x is nothing but my p is 1 and q is minus 2x by e to the power of x. Correct? So integration factor is e to the power of integration of 1 dx, which is e to the power of x. Solution is y into e to the power of x equal to integration of minus 2x by e to the power of x into e to the power of x. This gets cancelled. So solution is minus x square plus c. So from the options, c is the correct one. Okay. Next. Yeah. Thank you. So this is all the NCERT chapters, exercises, and information for the differential equations. This is uh, uh, not easy, I would say medium difficulty, but there are only 4 concepts in this, 3 to 4 concepts actually. You learn that every problem will fall in one of that actually. Okay, especially the last 2 concepts are very important. If you can identify the problem in one of that concept, okay, one of that method, then you can solve it easily. Okay, so yeah, I'll come up with more videos and more mathematics problems. Okay, thank you.